Hello. Okay. GSA to 2019. I feel like we've done this not too long ago. Like wasn't there a month ago? 2 months ago? Something.
I don't like this bit.
Like this is very deja vu. Right
Welcome
now.
to all
Look,
the people
I'm
that
under
you
a lot
didn't
of
see
stress at the
last
moment,
time.
and it's not my fault if I write November 31st in a fucking email.
I'm not even bleeding on that bit right now, but thank you for being the person.
It sends a lot of pent-up anger.
I sense.
How many of you know me? We've had conversations.
I was more or less saying that we did this 2 months ago for
We did
NAPC.
NAPC. And guess what? We've seen all the same talks again. So
No, not all.
No.
just go
Yeah,
watch
we
them.
haven't seen Curtis's yet.
I had someone else deliver my talk.
There we go.
She had new data,
That's better.
Yeah.
and now they're peeps colored.
Ooh,
They were, red shell, blue shell.
I missed that. It's unfortunate.
It was a
They were colorful.
yeah. I went to
Did everyone see penguins?
yeah,
Yeah.
sure, let's do that one.
Plus, now as visual content, I can be your penguin scale bar.
No, it's the tallest penguin to 6 feet.
But you need like an emperor penguin, scale penguin.
You can be our Emperor Scale Penguin.
King penguin.
King Penguin.
Okay, I missed the penguin talk, so you gotta fill me in.
Oh, so then this is Tracy Heath's discussion on the fossilized bird death model. And one of the model data sets that she used was penguins, fossil, and modern. But broader speaking, the kind of stuff that she was looking at was modifying the model so that you could kind of try to incorporate it with more different types of data. Like trying to get the model so that it could spit out a simulated stratigraphic range data set, and then also so that you could then use it to input stratigraphic range data and have it being used to get your evolutionary rates just from stratigraphic data. I think at least that's what I took away from it as one of the things that they're working towards right now.
Yeah.
So the fossilized birth death model is a evolutionary model which uses stratigraphic information and a birth death model and a sampling estimation to try and reconstruct when certain taxa first appear given your evolutionary tree. And this is expanding it out towards different audiences. Okay.
And having fossils
And
make the timing better.
yes. Yes.
It's always nice to see. So all of the penguin ecology stuff started to make more sense.
Yeah, so what was the test case for the penguins, Brendan?
They had 36 fossil penguins and 19 extant penguins, and adding the fossil penguins brought their divergence time up
I
towards
remember
the
this.
recent,
Yep.
towards times that make sense, because when you have circumpolar circulation and upwelling in modern ocean regimes beginning, you get diversification. And also you're splitting up continents where penguins live.
But yeah, it significantly improved it compared to the just strict molecular clock stuff.
Which wanted them to be way too old.
Yeah.
Yeah. Penguins are eternal.
Penguins evolved before the sun.
In fact, some say it was penguins that created the sun
Paradoxically, because they needed the heat.
to get the fish that they decided they wanted
Yes,
to evolve so they could
Of
eat.
course, of course.
Then they planted the daisies in order to...
No, now we're doing Daisy World. Now we're doing Daisy World. It's jet lagged and we're loopy.
No, we've been awake for 1,000 years.
Yeah, I have 8 hours of sleep over the last 2 days.
And then
That was a good talk, and unfortunately, I always say it's really good when you're being upfront chair of the session, but you actually get way less of it because you can't see the screen very well.
Yes.
And so that's why I don't
Yes.
have good memories of this
No,
talk.
yeah, no. This was a great talk. And a lot of it was like an introduction to the method, which was important because her talk in the very beginning was setting up what is the fossilized birth-death model, which has been a big thing in this session because there was a short course on also the fossilized birth-death model and incorporating it. So like a lot of the time was sort of set up with just review of the method, and she's instrumental in having pushed forward that and like first proposing that. Although I think some of the initial ideas behind that predate her, she's formalized it, and so like it was great hearing from her and hearing the way advocating for it and hearing the ways that it's being modified with both paleontologists and modern biologists in mind, and being modified to hopefully be able to incorporate lots of different data and lots of different uses. And I thought that was really cool. But because it's very much like a methods talk, I don't know how much we can talk about it.
I mean,
And then after that was the hominins.
Yes.
Which
Yes.
is the same method, and that was interesting because it was looking at, well, there was all sorts of talk that was fun, and if I don't know, have you guys haven't done the nil-eddy thing at some point, have you?
No, we avoid human evolution.
Okay. Well, there's a place where fossils come from where you have to be tiny to get them.
Right.
You could do it, Anna.
Yes, I could. I actually looked at that.
Yeah.
And
I did like the idea of there being this accumulation of hominid fossils, and they were setting it up to accumulate more.
It's a modern trap, but this time for archaeologists.
You go down there, eat a kind bar, can't get back out.
Oh God, I'm retaining water because of salt from flight before. Just leave me behind. So the joke that we're making is that this setup has a cave system which
Dennis is very sensitive to strings of in-jokes right now.
Yes. It has a cave system that goes deep down and then has what they call the Superman crawl, which is just like a flat, 10 inches?
there's the dragon arch.
Dragon's back.
Dragon's back,
yeah.
Yeah, but first you have the Superman crawl, and then you climb up to the dragon's back.
And then there's a 17 centimeter wide
17 centimeter,
spot.
that was it, yeah.
So you have to squeeze through the 17 centimeter wide spot to get to a new chamber of fossils.
I tested it like myself underneath a chair because I was like, oh, maybe if I don't do a master's, I can do this.
And
You need to be good
Then
getting
you-
to places.
So here's the thought.
Still.
Presumably you have to then get those specimens out.
Yeah.
And that means, yeah, but they're bones. That means you probably have to plaster cast them.
Now, when I saw they were taking out like a skull cap, they literally just put it in like a prefab, like almost clamshell type support, and then in just like a little plexiglass box, just
So they've got. I was gonna say so they've got like the avocado shaped Tupperware thing for just a skull, and then we go with it. Okay.
Oh,
Just run a hose down and suck it up with a Hoover.
like an old Warner Brothers cartoon. Just
well, it was National Geographic, so there's lots of good photo documentation of this.
Yeah.
And some pretty amazing figures too.
Yeah, the referring to humans as by their ontogenic terms was delightful because people often don't do that. And so referring to sub-adults and juveniles and neonates,
Yes,
it was
yes.
real good.
Neonate humans.
But yeah, no, they've got a lot of stuff down there. Well, not down there anymore. I guess it's up here now. But yeah, the thing that I thought was very interesting, aside from all the very nice figures, was the actual phylogeny and the what is Homo erectus, and at no point addressing the fact that Homo erectus is decidedly paraphyletic.
Yeah.
And so it's a genuine ancestor, and then that gets into taxonomic issues, which probably, if we are now realising or accepting the ancestral nature of species and that anagenesis can happen, you have to start accepting of the concept of...
Right, that actually did lead into, again, more of Tracy's stuff with the methods, where different ways of treating branching patterns as to whether or not you allow for cladogenesis being required at each moment of speciation versus speciation with an ancestor persisting, and that's part of the thing that was necessary to get stratigraphy into there in the first place. But then it leads to trees that look very different from your standard cladogram, because you just have one lineage and like 5 things coming off of it.
Yeah.
The bit that I thought was really interesting was they had the different skull regions.
Yes.
And so lots of things
By the
are
way,
integrative.
A face with no teeth, real creepy. Just the face part.
So this is partly a desire to see whether or not certain parts of the skull or certain parts of the face or certain parts of the head or other parts of the body are more or less homoplastic. Like there is a kind of assumption that, especially in some mammal groups, that the jaw for some groups might be particularly homoplastic or convergent because it's masticating,
right.
It's eating things, it's interacting with the environment. Therefore, it's directly affected by matter energy exchanges, and therefore more likely to be highly adapted towards subtle changes and therefore convergence.
Yeah, it was the concern, not that it's going to be randomly just more variable, but that it was going to show a bias to the moment you start eating softer foods, you're going to look like you're a clade, even though independently you've done that multiple times.
And so they wanted to test whether or not the differences they're seeing in this group that are pulling in one direction, which are based off of some of these characteristics, are being biased by something that could be highly convergent. And this is, I think, cool. It's cool for hominids. It's cool for a lot of other groups because these kinds of ideas that, well, we can't really work with these characters because they might be homoplastic is something that I think comes up a lot. Mm-hmm. And what they ended up doing is they did random subsampling, comparing. I can't remember how they ran the statistic again. It was this morning and I'm out of it. It's very late. I can't remember what statistic they ran to determine phylogenetic strength. But they did resampling to see whether or not part of the reason why they were seeing more or less convergence could be an artifact, or more or less signal, could be an artifact just due to the number of characteristics that were available in each region. And so when they standardized all of their data to sort of like bootstrap analyses, what they found was that they all had roughly the same amount of phylogenetically informative information. Mm-hmm. So net result for that would be it doesn't seem like anything is more or less convergent than anything else. There is no part of the skull that is just the good one that lets you know where it should go, and there's no part of the skull that is bad. It's just...
Sorry, 1970s.
And it's not just the teeth and the dentary. Like, with hominins especially, like, there's people who argue against various characters because they think that they have too many linked. Like, you're getting a big brain, so then you're going to shorten the face. Yeah. Like, that's something. Yeah. And the base of the skull being related to changes in cranial vault. And so it was cool to show no one was right, and their favorite system in the 70s for what part of the skull to look at wasn't better.
Well, the key to it was the bootstrapping, as Curtis said, because what she basically said is that signal is there, but it's to do with having fewer characters, and so there's more wiggle in your data. Yeah. And that's what we were seeing, and we were thinking it meant something that it didn't.
Yes.
All right.
Which, that was awesome.
That was really cool. Especially because the answer fit my preconceptions.
Sure. You know, it's... James, we can talk about something called... I was going to say, there's something called confirmation.
I thought it was going to be going somewhere, and it went somewhere else, and it really surprised me. That's all I mean.
I was more really surprised by the loud phone call that interrupted that.
Yes, I wrote that down. I wrote down because it was not somebody who then motioned to try to get their phone. Like,
they just sat there.
They sat there and they let it ring
for a while.
Yeah,
and then they walked immediately outside and talked to it on speakerphone.
Yeah, I could hear the phone call afterwards, but they let it ring for like a full minute.
Yeah,
that's very weird.
Yeah, that was
very weird.
Yeah. By the way, the clock system had 20 minutes programmed in, 15 minutes programmed in, 0 minutes programmed in. So you could set it to 0 and it would be a red light if you didn't want it. We had no introductory remarks. So when Dave got up, I switched it to 0 and hit play.
Wow. By the time I was up there with Lena, it had already been cleared a few times because after the first transfer, I guess whatever happened with Pete and Will.
Oh no!
Because we were 8 to 9 minutes behind by the time we started, and then it was myself and Lena basically just like no time for questions, and then we got back on track again, and we ended finally on track. At the last time.
I had no idea.
Oh yeah.
Basically, we left, and it just became chaos.
So apparently, all I got from Pete was no one's fault except Bill Gates. So I don't know if the computer crashed, and then everything, because also the speaker box had completely cleared, and so Lena was manually putting it in every time. Because the problem is that people were pressing the clear button as opposed to the reset button. And I saw Lena like, no, this one, this one, because she had hit it and reset and had to manually do the timer like twice. And like, no, that one.
Because
only one person went to it because it was expected that we wouldn't be trading out every two or three talks.
Talking about people with initials BG, how was Bob Gates' talk?
It was good. So apparently he talked at NAPC, and that was more focused on like just the taxonomic stuff, like just presenting what they found, I guess. I don't know, but
NAPC was a lifetime ago.
Okay. So he briefly went through the stuff that had recently been published. So Camber Aster, the new Mollisonia paper that just came out last week.
Mm-hmm.
And then he focused on just the mode of preservation there. So he said there was a lot of magnesium iron oxides, and he kind of also went through the history of like the Burgess Shale clay discussion. Mm-hmm. So whether it's original carbonaceous preservation or these aluminosilicate minerals, and where clays and when do they come in, the timing of them. And so he was looking at the fossils from this in cross section because apparently they have enough that they can cut them up. Don't give me that crazy look.
Slabbing some Cambrian Margashtan fossils.
They found a new site.
Surprisingly, they appear as this tiny little thin black line when you cut them in half.
Fascinating.
So when he was looking at them in cross section, if you expect that these clay minerals are occurring as the original preservation, that they'd be encoding like the entire specimen.
Is he looking for displacement?
So he's looking to see if these clay minerals are surrounding the entire thing, and they don't see that. So he's interpreting it as secondary, or after this metamorphic cooking of the carbonaceous, that the carbon is escaping, and then you see this void of carbon.
Okay.
And then a little bit on the outsides. So it was interesting. Apparently they have like a lot of stuff in the works, so this is just beginning.
Cool.
Apparently you can make like a little origami Cambrian Aster or something.
Yeah, there's a printout for it.
Oh, okay.
I don't know.
I thought this was with the sheets of tissue that they're clearly cutting up. Just make origami with them. It's the best origami paper.
Actually, if you work on the Burgess Shale every night, you get a meal and they just wheel out a fossil, and then you just go delightful, and that sustains you for the next day.
Morella essence.
No, there's over 1 million Morella. They're basically podlings. They're worthless.
Here's the X's to this Morella.
I saw Graham Lloyd's talk, which was very good. It was basically all graph theory. How to graph and communicate and look at the different trees that you can get.
Okay.
With the normal problem of the moment you have more than 5 taxa, you have an exponential number of potential trees.
Okay.
And so he was trying to find different ways to graph it, and you wanted it to be Euclidean, you wanted it to be so that you could put it on a square.
Yeah.
You wanted it to be... There was a series of things he had. And then you wanted it to be Sudoku.
What?
Predictable.
Oh.
That you could take a set of data and predict.
Okay.
And he's going through all the different ways that you can graph it. And the fewest dimensions possible so that our feeble human brains can comprehend it. And the...
1?
No, you can go up to 3. or you can do 3 or
We're just showing
maybe
cross
4.
section.
What you don't realize is that's actually secretly an entire other universe.
But the trouble is that graph theory is inherently broken, because the moment you have more than 3 things on a tree, you end up with 10 bajillion potential dimensions for it.
Well, because this is related to this is related to like plotting morphospace through time through trees, right?
Well, he just wants to plot the tree area. So,
Okay.
But it would be the same problem.
Yeah.
And so the solution he's come up with is to think of it as a sphere world, so that you've got the outer sphere, and then the next sphere, and then the next sphere, and the next sphere, and the sphere at the base is like your one taxon.
This is happening in
So
the
we've
Chronicles of
created-
Narnia.
Yeah.
And then you've got like 2 trees, and then so basically
We
the
both
way,
had the same idea.
the way I was envisioning it is it's like electron orbits almost.
Okay.
That's the way it looked to me.
It sounds a lot more like epicycles.
But,
Yeah, okay.
but he was saying, so what shape can you make so that you can fold it over and create a sphere? And so he was going through all this, and it was actually kind of interesting. And
It seems like a weird. It was actually kind of. It seems interesting.
How do we
He
make humans
actually
understand?
so he talked for 20 minutes and was setting everything out, and it seemed really cool, and like he was onto something. And he said, so I can get up to 5 trees, and I don't know how to go any further because I've run out of spheres, and so this is kind of useless right now, but it's a start.
How
And
can you run out of spheres?
he ran out of shapes that exist in order to be able to fold them into a sphere.
Okay.
And then he said, but he also had this thing where you need to be able to ordinate all the potential trees
Okay.
for the number of taxa. And so he said, I've hit one problem. There's Pyrate will do it, or whatever it is, we'll do it for you in R.
Yeah.
And he says, and so
Pirate is Python, so I don't think it's
okay,
R.
not Pyrate. Anyway, the thing he was using in R will do it for you.
Okay.
He says, so for this number of taxa, here are the 87 trees it produces. However, Felsenstein says there should be 88, so I'm missing a tree and I can't figure out which one it is. So he's like, I'm going to leave this up here. If you notice the tree that's missing, please tell me.
I just want on a milk carton. Just one cladogram just sitting there on a milk carton missing 1982. Please report.
But it was a really cool talk, and he's trying to think of things. He's trying to basically he's trying to wrestle with graphing something that is almost
Fundamentally
intractable.
ungraftable.
Yeah, and he's made real progress, but as he said, like there are very few things that are only 5 taxa in an analysis. The average number of taxa in a phylogenetic analysis, he graphed it, is around about 50
Okay.
these days, and he's probably looking mostly at paleo data.
Yeah.
But round about 50, there is a tail up to about 300 is the maximum size phylogeny that he has in his database.
Okay.
It does peak around the 25 to 50 range.
Okay.
And so he said, and so this is what I've done. What? It's like, this is useless. But if we can move further,
Yeah,
we can start. But yeah. So
I
I thought it was really cool.
it sounds like a very cool talk. It also seems like it's going to end when he finds a book that communes with the old ones. And he realizes that there are shapes outside of your feeble dimensions.
So here's the thing that he did do, and I don't know if he knew he did it, but basically he was like, so if you plot a 6x6 grid, and then he goes, how can you make this so they touch each other? Well, you turn them into pentagons, and I'm like, you've got pentagons in a 6x6 grid. It's not going to end well.
It's protective symbols, James.
What did he protect?
Make sure you draw it with your left hand.
You're trying to
Draw with
prevent
your left
whatever.
hand.
James, you're trying to prevent whatever is inside the sphere from getting out.
That's why we have so many.
The one true tree.
The one true tree is in there.
But at the very end of the talk, you realize that what you're seeing right now is you watching the talk in the talk as you're watching the talk in the talk.
And then the 88th tree walks in, and you think it might change its shape.
The 88th tree is the true tree.
And then Samuel sits down and watches the movie In the Mouths of Madness.
So yeah, it was a very good, and it was dealing with something. Basically, the entire talk was effectively communicating something that we can't comprehend.
Yeah.
And he did it so well.
That's
It
awesome.
was-
That's very cool.
yeah. He had 102 slides.
And how did he fold them in?
I don't know. There might have been.
He folded 102 slides into 20 minutes. He's definitely got like a hypersphere
Okay.
community with him.
One of the slides was just the Eye of Sauron.
James, the way you're describing this to me, seriously, I'm just imagining, like, he starts talking, and all of a sudden, it's like everyone blinked, and they just, that was a very good talk.
Well, no, I'll tell you
And
what.
then
That was
3
excellent.
days have
I'll
passed.
tell you what did happen, and this was very strange.
But there's a videotape of the blood sacrifice that nobody understands.
What did happen, which was quite strange, is I sat through Tracy's talk, and it felt like sitting through a talk for 20 minutes. And I sat through the Nadeli talk, and it felt like sitting through a talk for 20 minutes.
Yeah.
And I sat through
Well,
this
sorry.
talk, and it felt like I'd been there for 30 minutes, and I looked at the clock, and 10 minutes had passed.
Yours was running faster. Well, do you remember in Flatland when the Flatland people talk to the sphere and say, there could be higher dimensions, and he gets all mad at you? Did you get to that point in the talk? They're like, why can't you add a sixth sphere? No, that's heresy.
You're not fooling me. There's only 5 spheres.
There are only 5 spheres.
No, James.
I mean, he is stuck on 5 spheres. But
James. The great irony of this conversation right now is because he was so good at explaining something that is unexplainable. You cannot explain how he explains something so unexplainable. And that in and of itself is truly the mouth of
I'm
madness.
pretty sure he invented a shape at one point. Because it was like, so you could use pentagons, and then you could use hexagons.
Just
And then it was
screaming
like-
about shapes.
And so this one, if you use a hexagon and then a shape that I can pronounce that looked like a triangle with 3 extra sides, but it was 2-dimensional.
And the flesh of children.
And then he said, it nests in this, and it looked like it was stabbing
with
the
2
sphere.
exercises. That's 2-dimensional.
Yes.
But it undulated on the screen in a glistening, almost pearlescent flesh tone. like fresh cut lamb.
It was very unsettling, but it was kind of beautiful.
Okay.
So yeah.
I think it's Ezekiel that you've just described.
Here's the
We've
really
got spheres
interesting
within
thing.
spheres rotating, and sometimes they were fire, and sometimes they were not.
My memory at the moment is not the best. I have a very vivid, clear, almost crystal-like memory of that entire talk.
Because you were seeing the deep truth.
Yeah. And slow rumbling voices of the old ones spoke. Okay.
Yeah.
That sounds great. I feel really bad for our treatment of this
I
topic.
think you'd appreciate it.
Yeah.
I feel bad for missing this talk.
Yeah.
I had my chance to see the truth.
No, you don't
I
want
looked
that.
away.
Again, he's gonna wake up. I'm gonna wake up in the morning,
Look,
trying to draw
Brendan,
everything.
Brendan, how did you not want to go see the talk with this title? A new approach to visualizing the topology space of all possible phylogenetic trees. As long as there's 5 taxa. Or we make progress.
There needs to be a little asterisk at the end.
Yeah.
So that was the last talk I saw before I had to give a talk.
Yeah.
So I don't know what else. What did you go and see instead of that?
I think I
saw that.
sat
I
out.
saw that.
We saw your talk, so you must suffer.
No, you don't have to talk about my talk.
Oh, well, I even put in Lamstone Mark 1 so that I could tell which one was which.
Let's see, I don't know if I think I stepped out. I don't think I went to another talk until your talk.
No, because I went to 2 very good talks after mine.
Well, your talk was good, and it was a heterochrony talk, and it was cool, and everybody liked it.
Mm-hmm.
And then it was followed, so you went from, we should represent all organisms as spheres, and then after your talk
on that one.
was, all organisms are
Spheres.
perfectly spherical as we know.
So long as we model it. if
So
we
in between spheres and spheres, James talked about horseshoe crabs, which are decidedly non-spherical.
we're back to everything spheres.
Well, it's really good because my talk basically, the undercut of my talk is organisms are complex and we should not treat them as a single solid thing. And then apparently afterwards it's like, so organisms are spheres.
No,
We're gonna
no,
model
no, no,
organisms.
that's not what
We're gonna model
I know.
cells as
yes, it
spheres.
was cells.
Cells
Yeah,
aren't
it was-
organisms. Cells aren't.
Single-celled organisms are not.
No, that's not what he said. He said we're going to organise cells as spheres.
So this is trying to.
No, model cells.
This is trying to determine why some organisms prefer. Why most organisms tend to prefer calcium carbonate.
Why metazoa?
Oh,
Why
wanted
most
to-
metazoans
I wanted to
prefer
see
calcium
this talk,
carbonate.
the non-peripherant metazoans, question
Yes.
Sophie Westercott.
Yes.
Yes, I wanted to see this.
But we have radiolarians and sponges that all prefer.
And there's something. There was a new thing that I hadn't heard of before. An acanthotherian makes
Acanthotherian?
strontium sulfate
Yeah.
tests. I didn't know that, so that was fun.
There's
That
also
was a throwaway thing.
example.
Strontium, the strongest mineral.
There's examples of some like silica-based parts too that occasionally end up in more metazoans.
Like copepod teeth and
Yes.
brachiopod larvae
Yes.
and eggs of something that I didn't have time to write down before the slide moved.
I mean, calicerates do put heavy metals into the tips of their claws.
But that's not silica.
So
You can't have everything.
There's a
Talk-
magnetic snail.
Brendan, correct me if I'm wrong, but the talk seemed to be like, this is the model we're working on, and this is like, it seemed like one of those like, plant the flag, and this is what we're going to be doing for the next few years. Like, because I can't remember if there were conclusions or data.
So there were
some preliminary data.
There was some preliminary conclusions, and there was like modeling conclusions. So it was
Which is like, that's fine, that's good.
they
Like,
got
this is-
to. I think the affirmative conclusion was they figured out how much seawater with the current concentration of silica you would need to pump in order to produce a test of silica at various sizes of organism.
Because one of the thoughts is that it might be size biased.
And then sponges being the exception.
Yeah.
That was, I think, the next step was sponges could be the exception because they are already pumping so much water to feed that like it may not be that much extra effort or it may not be extra effort. And on the other side, there's the deep time perspective of the amount of
Silica in the
dissolved
oceans.
the amount of silica dissolved in the oceans available is, I think it was like 4 or 5 times as high.
Yeah, it's orders of magnitude lower today than it was in the past ocean. So the idea being that maybe it was more common for experimentation in a lot of different things, and it just so happens that when that ocean chemistry significantly changed, only the things that were smaller and therefore weren't pulling in as much or needing to pull in as much, or these sponges that had adapted specific characteristics to be able to pump in a lot of water, were actually able to maintain siliciclastic skeletons in the marine realm.
So the single cell type things could still evolve silicious skeletons because there was this big break where it becomes like logarithmic of how much water you need to deal with in order to make a skeleton if you're big.
Whereas calcium carbonate is easier.
Yeah, for now.
For now. That's foreboding and inaccurate.
Well, I'm going to talk about ocean acidification on Wednesday. So.
No, I mean, the PETM, there's very, very white sediments of calcium carbonate shells and not. You see anything else cool?
No, I went into hermit mode after like the first.
Okay.
We could actually like make a comment on James' talk.
We have a lot to get through.
Okay.
And we don't need to talk about everything we see.
No.
So I saw 2 plants. No, I saw 2 talks about plants.
Did you saw 2 plants?
Were they spherical?
Ooh, yeah. Did you find a barrel cactus?
No, continue.
So I saw Alison's talk, which is very good. I didn't understand most of it.
C4 plants.
Yes. Well, okay, I do understand most of it. So the thing was, there were very loud people in the corridor,
Oh,
and so I went and shut one door
okay.
and got up from the middle of the room to get out to go and shut one door. And then I went and sat down, and then the people that had been standing there moved to the other side, and then Mark got up and went and shut the other door. So, but Alison was giving a keynote talking about basically isotopes and looking at forest fire ecology
Okay.
in Australia. And the long and short of it is that the signal isn't what you'd expect for a place that was that dry
Okay.
and prone to fires. And it's probably because the community had evolved fire resistant strategies.
Okay.
And so the C4, C3 diversity that you would expect for something that was in this regime wasn't there, and so it switched to an alternative regime in response to the climate that was prevailing there. So that was a real dumbed down, simplified takeaway version of what I got from her talk.
Yeah.
I'm very sorry that I cannot present more of an in-depth view of it, but that basically was. It was a very elegant talk with lots of data. That's the sort of summary of it.
Yeah.
So.
Let's see. I saw. Oh, let's see. I saw April Wright's talk on ants. That was good. Mostly just looking at the different ways that we can use the FBD model again, and we can let a lot of different variables vary. And looking at the ant fossil record and its current distribution, and trying to come up looking at the different ways that we can run parameters to see why it is the way that it is.
Mm-hmm. Was it a school for ants?
What? Yes, it was a school for ants.
It was interesting because the parameter that seemed really important was
Fossilization
the
potential. Yeah.
So having different fossilization potentials in different windows of time was able to resolve which
the majority
of
of
these
it, yeah.
3 taxon problems was correct.
Mm-hmm.
We hope. Maybe. For the future. Is this real? Was the end of that talk.
Yeah. This was some cool prelim stuff.
Mm-hmm.
Like, and
What about you? Do you have
She
one
was-
you
she was her mode. She was still
Still
her mode at this
mode.
point.
Yeah.
The only other talk from the morning that
Davies Megatree. On all of crinoids.
Ali's talk.
Ali's talk. Will's talk was cool. I would like to talk about that one.
Yeah, no, that was good as well. But Ali's talk was really good.
Okay.
Ali's been looking at plant communities from the Miocene of Kenya, looking spatially and temporally at the shifts going on. And she was going through and saying, these are the fauna that you get there, and these are what these fauna indicate. And the reason why people are interested is because you get hominids there in the Miocene. And she said, so when you get hominids, that means it's a forest, because you find hominids in the forest.
Okay.
But nobody's actually been looking at the plants. So she's been looking at the plants. First of all, there is it's so well preserved that you can see here's this lush area, and then you walk 100 yards, and it's now it's swampy, and
Okay.
you can see that you've got the shift preserved.
Yeah.
Temporally, going through it's shifting from more of a savanna-like regime
Okay.
to a rainforest-like regime. Hominids occur throughout.
Yeah.
So they're not indicative of a certain environment, and the thing then that's happening, which people were missing until she was looking at this, is that hominids in the Miocene were very adaptive and just made do with whatever environment they were in. So they did not need to be in forested areas like people think.
Yeah. No, it's just realizing that we've been doing it for years. Just making do and assuming it'll be fine.
Yeah. So that was very good. Ali's talk, she's a very good speaker. It was really good.
Cool.
So.
Last talk of the morning I want to talk about, unless Brendan, do you have anything?
I would talk about the Carlotta Mori and John Hendricks talk.
Oh, why don't you do that?
So the Dominican Republic is fun and it has lots and lots and lots and lots and lots and lots of mollusks.
Okay.
And it was 100 years ago. There was a kind of big race to publish between Carlotta Mori, who's is she the first female
But not
doctor
the
or the first? She was one of the early women to be issued a doctorate in the United States.
Okay.
And she, when somebody else came to dominate the Academy of Natural Sciences in Philadelphia, she was no longer allowed to look at the specimens there, and so she went to the Dominican Republic to collect her own new specimens,
Okay.
and then ended up in a race to publish where she won.
Hell
And so in 1916, she published, in 11 months from field work to putting out, a 300-page, 40-plate monograph on all of the mollusks 4 days before the rival publication came out, thereby securing all of her names as real names and their names as not real names, which then resulted in a snarky admittal of defeat where she was referred to as Miss Mori, that John pointedly crossed out all of the misses and wrote doctor in on the slide. And the other things were that lots of the families in the Dominican Republic are still not well studied. So, like, the Archids are the most diverse bivalve family there, supposedly, and they haven't been treated modernly, and several other things. And I think it came close to the end saying, like, well, we can't ignore turrets forever, so someone has to do paleo turrets. But, yeah, so 18% of Dominican Republic families have been looked at in the last 100 years.
Wow.
Because everyone stopped in the 30s.
Were these snails or?
Snails and bivalves.
Okay, because you said Dominican Republic families, and I really thought humans for a minute.
No, I don't have any Dominican Republic human things. Just mollusks.
Okay. So last talk for the morning that I saw was trying to figure out what happens when things go to water, specifically tetrapods, because there is a pattern where even though tetrapods have come out onto land, our group that has 2 arms, 2 legs, usually, and a backbone, keeps going back into the ocean.
Mm-hmm. And
they change.
They get big.
They get big. Well, that usually.
Yeah.
Usually. If we take a look at things like ichthyosaurs and mosasaurs, or we take a look at whales,
cows.
Sea
I meant
cows.
sea cows.
Sea cows are not okay. That's your fracking joke.
No, it's not a fracking joke. I meant sea cows.
Okay.
And the other one, sloths.
In a sense.
So, most of the
They
time,
There
they
is a
Big when they
marine
go in the water,
sloth.
the sloths.
Yes.
You sent me a drawing once that I can't find anymore because I think Twitter deleted it.
Oh, the diving sloth.
Yeah,
Yeah.
just like
You chilling down there.
Yeah, just go down there. And so, this is possibly again associated with diving. If you're bigger, it's easier for you to then just sort of overcome your buoyant mass and go down for depth for food. So it was like, cool, let's look at other things. Let's look at snakes. And turns out, snakes are weird.
I mean, for a start, they've already given up their legs, so they're really only honorary tetrapods.
They're halfway between tetrapods and worms. Is that where you're going?
Yes, they're almost in Anna's purview. But they go into the water.
So for first thing, he ran a lot of criteria based upon environment, and snakes do not vary their average size based on environment at all. Doesn't matter if you're in tundra, in the desert, in freshwater, in saltwater, in brackish water. Does not matter. Snakes are on average about the same size.
Probably by taxonomic group. Pythons are on average larger than your viper, thankfully.
Sure. No, yeah, but it's
Pythons
just...
also, historically, there's like a Python global temperature scale for like tropical python size and temperature.
That comes into it.
So is that not a thing now?
No,
No,
that's
That's the thing.
Okay.
Temperature is the most important thing.
yeah. Snakes like real hot water.
Yes. If they're going into water, they prefer warm water.
Why are you looking at me? Okay, I'll heat the water.
So, yeah, they find that the temperatures closer to tropical snakes are indicative of the types of temperatures they see for freshwater, saltwater, and brackish water
Yeah.
snakes.
And he said there is a shift in body size. It's just not the same.
Not as
magnitude.
much, yeah. It's a very slight shift. Because
He did say this is a statistical difference, but like the error bars were overlapping completely still. So like it is a statistical difference that the eye cannot see.
Yes. And then again, I'm saying like pretty much average, but it's an average body size. So clearly there's huge snakes, there's small snakes, but an average in any given region, the size of snakes, probably the variance changes with the average body size. Is
the thing
pretty
I thought
similar.
was really interesting is cold snakes are very small, and I'd have thought that would have been terrible for them, but it was just there. So that to me was real.
Yeah, that was the
interesting.
one that had a very significant body size shift.
Yeah,
Tundra snakes.
tundra snakes, snakes in the
New fear.
tundra.
New fear. So then
I
the
don't
thought
know, they'd be
was,
warm. Like at least if you're being eaten by a snake, you're not going to be cold.
Well, I feel like they'd want to snuggle though. That's the problem. It's like if you're warm, they're gonna
I
want
just
to
want
come.
to boop.
They're friendly snakes.
I want to boop. I want to boop. So
Tiny snake.
the interesting thing that they
Next.
So with this idea, okay, well maybe a tropical distribution, or at least in a warmer climate, is an important component to getting into the water. And so this was one of many different hypotheses that could actually be tested by using an entire tree of all the snakes in the world.
Was it literally all of them?
I think it was all of them. It was or at least a significant sampling, because it was one of those huge GenBank trees.
Uh-huh.
And then running analyses to see different habitat preferences, and then also trying to see covariation of different characteristics to see whether or not they fit specific models associated with moving into and out of an aqueous environment. So an idea could be that it could be adaptive. You see a slow change. That change is associated with a higher probability of you living in an aqueous environment. And when you see that change completed, you have now adapted into that full aqueous environment. So like, oh, this thing is allowing for me to go to salt water beforehand, and it's slow movement towards that characteristic.
Yeah.
The other option is exaptation. A characteristic rapidly evolves before you've actually changed your environment, and then you see occupation of the environment. And then the final is non-adaptive. You don't have any change whatsoever. You move into the environment, and then you change.
Yeah, this was the underarching problem in my talk of like these three things are what can happen, and you need certain sets of data to be able to tell that, and in deep time, it's often very hard.
So he had a lot of data to be
Yeah.
able to do that, and it was still kind of messy, but it showed patterns, and most of them were exaptations.
Yeah.
Like associated with temperature was one of the ones again that we
Uh-huh.
kind of talked about.
Well, he sort of said like the snake needs to be near water before this can happen.
Elevation was the other one.
Yeah.
The high elevation snakes were the ancestors to the snakes that were going into water were at lower elevation than the higher elevation ones. So
You can bring a mountain snake to water,
but you can't make it swim. There were a few other ones that I can't remember off the top of my head what all the characteristics were, but I do remember that most of the patterns were exaptive, that you needed to get into an environment that was then capable of you, through historical chance, being able to occupy that new niche space.
and then you started adapting to it.
Yes, and that was cool.
That was neat. No, that's very good. I do like his work in general. We might have podcasted on some of the papers that have come out of snake work before.
Yeah.
It's very cool. So.
Then we saw talk about worms.
Yes, there was a really cool worm talk that was very good and worth at least $100.
Yes,
It
at
was.
least $100.
Yeah.
Yeah.
I would have paid $100 to see that talk.
I'd buy that worm for $1.
These ain't no cheap worms.
Yeah. But because the stuff's not published, we can't talk about the results too much.
Yeah.
But it's a very cool worm that now has a head, I guess.
It does.
But
Still no butt.
no butt.
No
Buttless worm. It's a terrible life.
Actually, we think that the holotype specimen may have
May have a butt.
a butt, but it's like too thin to even like try prepping out.
So it's a thin butt.
Yes.
Yeah. Gotcha.
It's a terrible shame because worms really don't get a chance to work on leg day. But no, it was really cool, and you did a ton of detective work at a cross-country trip to reunite the two halves,
Yes.
make them whole.
And this is like not the first time this has happened where they've separated a holotype part and counterpart
They
within the
sometimes
Palaeoscolecids.
Okay.
They've actually collected.
Sometimes people do it because they think it makes it more safe, because in case one of the museums goes under, the other half is still out there.
Well, this has happened before where they collected one half or like the part of Palaeoscolecids and left the other part in the field, and it was collected like years later and then reunited. I don't know why, but it seems to be a pattern.
We're also forming a pattern where we keep going to like things that could otherwise describe fantasy movies. And I put them together. And then the sixth sphere appears.
No, she's reforging the holotype.
Yes.
Yeah.
And when that happens, I'll go defeat the great evil with the worm.
Or the worm will save us.
Yeah.
Hello, my name is Anna Whitaker. Do you have 6 fingers on your right hand? You got that reference. No.
I did. I'm working on all my
Things that
references.
shouldn't be remembered.
Yeah. So what was the title of your talk? Oh, hang on, it's right here. The worm is in the detail.
There's a surprising number of like worm
puns.
Worm puns.
Yeah, you didn't go for the worm turns.
Not yet.
The worm has turned.
I
you
just
wanna
go down the Wikipedia page of worm puns.
Do you want to do the early bird catches the worm and then go, but not this because it's the Cambrian and there weren't any birds?
There was in the phylogenetics section, almost a significant number of people basically made jokes about how their work was more interesting than dinosaurs.
Was it ironic?
It was everyone, and then one bird worker said, "Finally, we get to talk about the interesting dinosaurs."
Sounds like it was a bloodbath the moment I stepped out of that
It was
room.
weird.
It's like, I like the fact that I'm just sitting there going, gotta give my talk, okay. And then apparently like everything was on fire in the room that I just left.
I don't know if it was like that, but I do like the idea of just an actual fire and just everybody like.
Well, I left and apparently Bill Gates came in and just karate kicked the projector. But yeah, no, so there was a really good worm talk.
The other like first couple there were really interesting. I really did. The one before me was
network analysis.
Network analysis.
It's. As I said to Curtis during the talk, I don't know enough about network analyses to differentiate between the studies. The thing that was interesting about this was the suggestion that the predators are specialised and the rest are not. That was interesting, but I don't know that. I can't understand the details of the stuff to say why it got that. Why that was the result it got.
And so the speaker is apparently coming from like a purely mathematical background.
Yeah, it was kind of like looking for traces, an expected distribution trace if you were a mesopredator versus a tertiary predator.
And that's a really interesting data set to use. You don't hear a lot about from that quarry compared to like the Walcott quarry or something. So.
Yeah, beyond that, I saw dogs in Raffinaskina, and that was pretty much
I
it.
saw dogs and 2 pistols.
Okay. Brendan.
I saw dogs, and I saw dead men do tell tales about mollusks in death assemblages in Jamaica.
What is it with the mollusk talks always being kind of weird?
Kind of a little bit macabre.
Yeah.
Alright, so the fun bit was apparently there were like 3 talks in a row that were alliterative, and they went all A's, all B's, all C's, all D's.
Yeah, we walked into the D talk.
And I only came into the D talk.
Yeah, the D talk was dogs, death, and dietary breath. Or dog, I mean, it could be dogs, death, and dog breath. The link between species duration and dietary specialization in canids. this talk, it was a very good talk.
Pizza and
Wolves
Sean.
eating pizza. It's like wolves are carnivorous, and it's like here there's a wolf like just grabbing a watermelon, a wolf running around with a pizza, and a wolf in a goddamn tree, and I don't know what it was eating.
It was a whole pizza that was rolled up.
Yeah.
It was a very interesting picture.
Everybody loves pizza.
Like a newspaper. It was holding a pizza, a complete rolled up
It was
pizza.
like a shawarma, but a
How
pizza.
did they fold it?
And-
What?
Hashtag
I think it
wolf
was
song.
British Columbia,
The
so
new
a nice
conspiracy
Canadian
theory.
just provided it.
So that was.
Wolves have a secret.
What was the one in the middle eating? It was in a tree.
It was
a
in a
wolf in a
tree.
tree. I
Like,
want to say it was
it was-
insects.
Like it was well they do apparently they do eat insects, which is weird. But I mean when I mean
Dogs love eating cicadas.
well cicadas because cicadas are like
high protein?
They're juicy.
Love,
Yeah.
Things love.
yeah, but they're also noisy, and dogs have got the attention span of like a 3-year-old goldfish, and so that's actually really old for goldfish. But like it's like it makes noise and it moves. Oh. So then it whittles in my mouth. Oh, that feels funny. Chomp. But no, the one in the tree, like when we said it was in the tree, it was like that tree should
Like-
not have been able to support that.
like
wolf.
like Baloo.
It was like the branches were like sticks, and it was just standing in it. It's like
If the dog were your toddler, you would be concerned.
Also, I appreciated the chunk dachshund.
yeah, it was a real,
I
that
kind
was
of
a-
felt
that
bad
was-
for him. That was
That was a dog that was 5 times the size of what that dog should have been.
it was not healthy.
But yes, basically looking at dietary breadth and species durations, and the result is the opposite of what we think it should be, in as much as specialists seem to live a long time.
Yeah.
Which is the opposite of the trend that we normally suggest. But with the caveat of there are phylogenetic considerations, which this talk did not look at because that's what's being worked on now.
Yeah.
And also humans are involved, and who knows what we decide we want to kill.
Well, and they specifically mentioned that phylogenetic data was there. It was just not being talked about because the error in conflict was more complicated.
Yeah, because the direwolf, Canis dirus, is a massive outlier, but then he showed 2 trends and said, so you see Canis dirus sits on this other trend. There might be a reason for that, and it might be phylogenetic, but
The other ones were that was
the other one was
only
human
member.
extinction.
yeah, we either killing things that we think are scary, or more likely, I probably killing things we think we're competing with. And if you're a dietary specialist, we're less likely to compete with it than a generalist. So that could be partly what's up at play.
Oh, and the interesting bit was to do diet. It was based independently of dental morphology. They were doing the microwear to figure out diet.
Yes.
Yeah, that was cool. So that was very good. And that was the last talk I saw lots of posters.
Raphnaskina was, hey, let's try and use morphometrics to figure out how many species we have of Raphnaskina. And probably the answer is a lot less than have been named.
I really like that.
Yeah.
That's really cool.
Yeah.
So there's either a degree of ecophenotypy, or it's just a very plastic.
So, I mean, Raphnaskina has been one of those, you know it when you see it, but in terms of species of Raphnaskina, like alternata, there have been studies just talking about the morphological shifts of alternata are kind of out there in terms of morphospace. And so, like, what they they did a original, just a straight PCA analysis, and everything overlapped with everything. Like, so then they did a PCO. But it was like a mixed PCO, where there were still continuous characteristics that they included, but then there was also like a lot of discrete character analyses. And the goal was to still make sure it was all external characteristics, or majority external characteristics, because for the majority of Raphnaskina, if you're collecting this brachiopod, you're not able to actually break it open and see what it looks like on the inside, even though those are the characteristics that seem to be the most important for actually identifying a lot of these
You mean
things.
you don't bring your field synchrotron?
Yeah. Well, what I'm saying is that we don't take our little chisel and break it open and pray to God that it's hollow inside so we can start looking at the internal shell anatomy. That looked like it was a little bit of the cardinal process. I'm going to go over there and check that out now.
You need to close your eyes and breathe deeply.
And then you'll
And
inhale
open
all
the
of the
sixth
silica.
sphere.
Yeah.
And then
What's calcium carbonate, sir? Calcium carbonate, sir.
they can be silicified.
Not at that size. So they end up with like 4 or 5.
That sounds like the right number of
Yeah.
species.
Yeah.
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 That you
There was still
you could graft those species into a sphere.
there was
We can't have any
Using
more.
5-sided triangles.
James. Speaking of spheres, with
I want to
extra,
see your
made of triangles with extra shapes and eyes that look inward.
We forgot the fiery crown that they were.
Yes, of course. One of the things that did get asked was, so, I mean, Judy and Max have been doing this 3D morphometric stuff, so I know this is all 2D, but what if you included geniculation and 3-dimensional characteristics? Do you think that could break out some of these further? And the answer is, yeah, probably. So we'll see. This is still ongoing. It's possible that some of this stuff could be further revised, but at least the idea that Raffinaskina is oversplit, I don't think you're going to find too many people that are going to really argue with that one. Yeah. Maybe I'm wrong on that. Who knows? Maybe there's somebody who's just...
There's probably someone
Yeah.
very defensive of their many, many Raffinaskinas.
I have no strong opinions.
Nope.
Did you hibernate for the rest of the day?
Pardon?
Did you hibernate for the rest of the day?
Yeah, pretty much. I was talking to people. So.
It's important.
Did you want to talk about either of the posters?
Yeah, I saw 2 posters. One was Matt Dowland's poster.
Mm-hmm.
They've finally got the CT scans of the palpomannid. Palpomanids are interesting because their first pair of walking legs are really robust and long, and they actually eat other spiders.
Okay.
And so this is the first fossil palpomanid that's not from amber. It's also the oldest. He's got it in a phylogeny, and it occurs in a family which is not a New World family. So that's cool. We chatted generally about stuff, but that's the poster. So it's presumably on the side. It's got the eyes and stuff, all the CT
Oh,
scans.
wow.
They now have a synchrotron that they use in the department.
Wait, what?
Yeah, they did it in-house.
Wow.
Okay.
So, and then the other poster was Megan Bonk looking at bite marks on marine mammal bones from the Miocene. Wanting to do stuff with maybe megalodon attack style, but the trouble is that nobody is really cataloguing the diversity or occurrences of shark bite marks. So it's basically asking for people to look through collections themselves, and just cataloguing different bite marks, what animals they occur on, what part of the animal they occur on, and whether it's a grab or a chomp or that kind of thing. And so she's just collecting data at the moment. But it's odontocetes for some reason get bitten a lot. You can say occasionally you can see things that have healed, so you know it's like a failed attack. You cannot tell the difference between an attack and a
Successful.
scavenging.
Oh, okay.
Yeah. But there's also they like the limbs. They really like the limbs, and trouble is
You can rip and tear and pull piece off.
yeah. But as well as that, they fragment the bones a lot, and so a lot of these things are mammalia or vertebrata.
Okay.
So yeah. So that was cool. That was very cool. She wanted more data. So if you have a bunch of mammal bones, look through them. If there are shark bites on them, let her know.
Okay.
So, Ashley's almost dead.
Okay. Well, I guess in that case, I got nothing else to add. You good?
Oh, great.
Okay. You need to sleep. You need to sleep.
I do whatever you tell me.
healthy working relationship. Let's turn this off. I don't know how to turn it off, James.
Okay, we can do that.